Assalamu alaikum. Hope you all are fine. In the last lecture, we studied different classes of steroid, and in detail we study sterols and bile acids. In today's class, we have a topic cardiac glycoside, which is another class of steroid, and these steroids are present in the universe in the form of glycoside, and they show powerful effects on the heart or cardiac muscles. That's why they are called cardiac glycosides. Let's see some of their structural features which are important to understand because of they are related to its cardiac activity. It has a glycan part which is steroid nucleus, and at 17 carbon a lactone ring is attached, and its glycone part is attached at carbon 3. Other features include, as it has steroid nucleus, so steroid nucleus is containing cyclopentanephenine ring at 3 carbon. Hydroxyl group is involved in glycosidic linkage. As far as ring fusion is concerned, so ring A and B is fused by cis fusion, while B and C rings are fused by transfusion. Cis and transfusion we have already discussed in our last lecture, where I told you that in transfusion, both the atoms or group of atoms which are attached at the junctions of two rings are on axial position. So one is above the plane of paper and one is below the plane of paper. While in cis fusion, both the atom or group of atoms are above the plane of paper because one is attached at axial position and other is attached at equatorial position. Additionally, hydroxyl can be attached to other carbon atoms like carbon 5, 11, and 6, 16 here. And a lactone ring must be present at carbon 17, which is the part of cardiac glycoside. Depending upon this lactone ring, they are classified into cardinolides and bufadinolides. In cardinolides, this R substitution is 5-member lactone ring which has single double bond, and in case of bufadinolides, this R substitution is 6-member lactone ring having 2 double bonds. So cardinolides has 23 carbon containing compound which is steroid, 23 carbon containing steroid, and it is the type of cardiac glycoside which is more prevalently present in the nature, and it has 5-member unsaturated lactone ring at carbon 17. And let us see some of their examples. It includes digitalis glycoside, which include digoxin, digitoxin, G-toxin, and other plant, Strophanthus quietus, also had cardiac glycoside, which is obane, all having 5-member lactone ring at carbon 17, and a sugar molecule at carbon 3. In bufadinolide, the steroid are of 24 carbon containing, as it has 6-member lactone ring, and bufadinolides are homologous of cardinolides and has two double bond lepton ring, which is attached again at carbon 17. The example include Schoolberg glycoside, which has glycoside silyrin, 6-membered lepton ring, and at carbon 3, it has glycone part, which is sugar moiety. As far as structural activity relationship is concerned, its structure is very important for its cardiac activity, and to obtain its optimum cardiac activity, it has a glycone part, which is alpha beta, which possesses alpha beta unsaturated lepton ring, which is attached at carbon 17 of steroidal nucleus, that is cyclopentane of nanothrene ring, whereas ring A and B and C and D should have cis configuration, The A-glycan part is responsible for its cardiac activity. So upon cleavage of glycoside, the A-glycan part retains its cardiac activity. However, the sugar portion is responsible for its solubility and absorption as well as its distribution in the body. Also, the oxygen substitution on the steroidal nucleus is also contributing to its distribution and metabolism. More the hydroxyl group attached to the molecule, the more rapid, more quick onset of action will be resulting. So let us see some of the sources of cardiac glycoside, and first of all we see sources of cardinolides. The term digitalis is used, which is representing a group of cardiac glycoside, which include most importantly digoxin, digitoxin, and ovane. These are the most important glycoside. Let us see some of the pharmacognostic features. So digitalis purpura belongs to the families Scrophulariaceae and is also called Phosphoriferica, and their part which are used are dried leaves and belong to the chemical class digitalis glycoside. Other species which are used as a source of cardiac glycoside, it also includes digitalis lineata. So the digitalis lineata and plant of digitalis lineata and digitalis purpura, both are the source of cardiac glycoside of class which belong to the class cardinolide. So let us see some of the chemical constituent of digitalis lineata. It includes lanetoside, digitoxygenin, which is a glycone part, and a glycone part, which include glucose, acetyl digitoxose, and digitoxose. Whereas lanetoside B include G-toxygenin, which is a glycone part, and its glycone part includes glucose, acetyl digitoxose, and digitoxose. Whereas digoxin has a glycone part, digoxygenin, and digitoxose, which is glycone part. Now, chemical constituent of digitalis purpura include perlanoside A, which has a glycone part, digitoxygenin, and glycone part, glucose, digitoxose, and acetyl digitoxose. And perlanoside B has a glycone, digitoxygenin, and a glycone part, that is glucose, digitoxose, and acetyl digitoxose. Whereas digitoxin include has a glycone part, digitoxygenin, and digitoxose, which is glycone part. Let us see how their substitution occur. It is a steroidal nucleus. it can result in different aglycone part after substitution. So R1, 2, 3, and 4 are basically substituted by different groups and resulted in different type of aglycone part of glycoside. In case of digitoxygenine, and even in all these type which are belonging to cardinolite has lactone ring, which is 5-member lactone ring attached at carbon 17, which is represented here R1. And in case of R4, which is also substituted by hydrogen group in all such cases, digitoxygenine, deoxygenine, and getoxygenine. Whereas R2 and R3 here, which are different and in 3 different cases. When we talk about R2, these are same in both cases, digitoxygenine and decoxygenine. Let us see here. See, these are same hydrogen group, whereas in G-toxygenine, this is hydroxyl group. So now come to R3, which is same in the G-toxygenine and G-toxygenine, where both are hydroxyl group, both are hydrogen group, hydrogen atom, and in case of deoxygenine, it is hydroxyl group. See here, G-toxygenine having hydroxyl group, sorry, this is hydroxyl group, which is present in 3 of deoxygenine. This hydroxyl group present in deoxygenine. Okay, now full structure of glycoside in case of deoxin and digitoxin, which has the glycone part in case of deoxin and deoxygenine, in case of digitoxin, digitoxygenine represent its glycone part, and also at carbon 3 sugar moiety is attached, and a lactone ring, which is 5-member lactone ring, because these two are belonging to the class cardinolite, which is having unsaturated 5-member lactone ring attached at carbon 17. This important structure is responsible for their cardiac activity. These glycosides are positive inotropic, means increasing and producing positive inotropic effect, increasing the contractility of the heart, and that's why increasing the cardiac output. And it is also negative chronotropic, means decreasing the heart rate, and useful in heart failure with hypertension. So it normalizes the blood pressure. Because of their effects, cardiac effect, they can be used, they are used in different conditions. The absolute indication includes chronic congestive heart failure, which is associated with atrial fibrillation, and relative indication include heart failure, which is not responding to diuretics, and atrial fibrillation, atrial flutter. Even atrial flutter are the condition where the heart rate is even increase up to 300 per minute, as it is negative chronotropic agent, so they are decreasing the heart rate, and also used in proximal atrial tachycardia. Tachycardia again means increased heart rate. So these cardiac glycosides are negative chronotropic and decreasing the heart rate. Another family of other plant which has cardiac glycoside class cardenolide include Strophanthus combi and Strophanthus hispidus, and belonging to the family Apocynaceae. Their dried ripe seeds are used, and which are collected when they are ripened, means they are when they are ripened. So they are ripened in June and July. So in this season they are collected. As far as their chemical constituent concerned, so it has active constituent, that is glycoside, strophanthin. On hydrolysis, it will result in a glycone part, which is strophantidine, and a glycone part, sugar part, which is alpha D glucose, beta D glucose, and beta cymerose. Apart from this glycoside, it also has fixed oil, resin, mucilage, and nitrogenous bases, include trigonylin and choline. See its structure. It is the whole structure of strophanthin, and strophanthin has a glycone part, steroidal nucleus, and 5-member electron ring, which is strophantidine, and the sugar moiety is attached at carbon 3 by glycosidic linkage, which include beta D glucose, alpha D glucose, and beta D cymerose. As far as its effect concerned, so they produce their effect cardiac stimulant and diuretic. Now, the plant which which is the source of bacadinolide, it is white squid. Its botanical origin is Erginia maritima, family Liliaceae, and its dried fleshy scalp of bulb are used, and which are collected in August, where outer scale is removed and inner scale is divided into pieces, and these are then sun-dried. Active constituent include scalerin, which is a glycoside, and upon hydrolysis, it results in scalerin having 6-member electron ring. Why? Because this glycoside is the example of bufadinolide, where the electron is 6-member electron ring and having 2 double bonds. Similarly, it has sugar moiety, which is attached at carbon 3, rhamnose, and glucose. It is importantly used for hematic purpose, producing emesis and expectorant in cough preparation, and used as cardiac tonic, and also produce its diuretic effect. So it is all about today's class and today's lecture. Thank you so much. Allah Hafiz.